Hi everyone, I just wanted to do a quick video to remind you about how to use your graphics display calculator to solve a trigonometric equation. Now, specifically, I'm going to have a look at this example here, example 22, which is an application problem, and it's part B that I specifically want to have a look at. So you can see here it says the function given by this long thing here can be used to model the height of a passenger above the boarding platform on the London Eye. Part A is use this function to estimate the height of a passenger above the platform. So this could be just a matter of inserting it into your calculator. But let me show you how we could do this. So I'm going to switch over to my calculator view now. I'm going to create a new document and I'm going to add a graph to start with. And that graph is going to be this one here. So we've got 67.5 cos, 67.5, and I'm just going to type it in. If you don't want to type it in, it is in the trig button here, under the trig button, 2 pi 30. So I can just type in the word pi over 30, and then you've got t minus 15. So if it just said t, by the way, you would go times by, and instead of t, we put x because the function is in terms of x, not t. You don't need the times there if you're using brackets, but I'll put it in anyway. T minus 30, close bracket, and then close bracket. Sorry, T minus 15. And then I have to add 67.5. 67.5. Return. I've done it, haven't I? Put the T in. Silly me. So I'm just going to go back to my inserting my function again. So I'll go back to my graph edit here. I'm going to use my up arrow, and that'll take me back to my function. And I'm going to replace the T with an X. I didn't mean to, but I'm going to keep it in the video because it's worth you seeing how to fix that mistake if you do put the T in by mistake. Now when I press return, I've got what looks like a parabola, doesn't it? But it's only because I can't see the whole graph. So you can sort of see that the function is 67.5 multiplied by this thing, which has a maximum value of 1, and then another 67.5. So what's that? 120, 135. So I'm now going to go to menu, and I'm going to go to window zoom, and then I'm going to go to my window setting, and I'm going to say the X is going to go from -1 to, let's see, I might just try, it says T minus 15 here. I might just try 15 and see how it gets me. I might need to change that a little bit. So from -1 to 15, the -1 is just so I get an axis, and the minimum is -1 for Y, and we are going to go to what, 140, something like that. Click on OK. Oh yeah, that was not good enough at all, was it? I should have actually, if I was thinking sensibly, I should have gone, 2 pi over 30 will give me what I think is a period shift of what, 30 minutes, won't it? Because of the 30 down here. So I really should have picked that straight away, but that's okay. We can fix our mistakes, and that's why I'm keeping it in the video. So I'll change the maximum to 30, click on OK. There we go, that looks pretty good to me. So that's the graph done. And then it's saying, use this function to estimate the height of a passenger above the platform 8 minutes after boarding. So if it's 8 minutes, that means that T must be equal to 8. I'll just show you, I'll give you a hot tip here. Now that we've defined the function f1 of x, if I now add a page, I'm going to go Control Doc for plus page, and I'm going to add a calculator. If I just go f1 of 8 like so, oh, there we go. There's the answer, 74.5557 or 74.6. And if we have a look at our answers, fingers crossed, 74.6 meters. After 19 minutes after boarding, I can now just go F1 of 19 because F1 was defined in 1.1 there. And hey, 112.666, so that would be 113 to 3 significant figures. So if I scroll down, I should get that. 112.7 or 113 to 3 significant figures. Now, this is the bit that I really wanted to show you, though. Part B, use the function to estimate how long it takes for a passenger to first reach a height of 100 meters. And I might just change this to reach a height of 100 meters for the second time. Okay, so what we do is we see that the height has to be 100 meters. So we go to our graphics display calculator, back to our graph, and we add a new function. So Control and G gets us a new function, and we just put in that new height of 100 meters. This creates a straight line graph, and this says everywhere along here is 100 meters. So that means this point of intersection and this point of intersection is where we've got 100 meters. So if we go to the menu and we go to Analyze Graph, we can choose Intersection. We click to the left, we click to the right, and there you can see we've got x equals 9.9 at 100 meters. And that's what the answer is there, 9.90 minutes. That's just 3 significant figures. But if you were asked instead, what is the second time that the passenger gets to 100 meters, then you would simply go to the intersection and say, well, that's the first time it intersects, that's the second time it intersects. So I'll go either side of that point, click and drag that out of the way so we can see it, 20.1. So the second time it'll get to 100 meters is 20.1 minutes. And that's what you'll write down as your answer. So make sure you practice this, because it's a really fast way of solving a problem when you've got access to your graphics display calculator. Imagine trying to do this by subtracting 67.5 from both sides, then dividing by this and so on. It would be quite difficult. But as a graphics display calculator question, it's actually pretty straightforward as long as you know what to do. Okay, I'll leave it there. Any questions? Don't hesitate to email me.